Hello and welcome to my channel. I'm Akram and you're watching Knowledge 360. In the previous video, we had covered the topic of returning clause in PostgreSQL database. And in this video, we are going to discuss about the from clause in PostgreSQL table expressions. And this is the first video of the series queries in PostgreSQL. So let's understand what is the from clause and how we use the from clause in PostgreSQL. Mainly the from clause is used to filter out the data to join the tables, and there are many more options available in PostgreSQL from clause. So let's understand the table expressions and the from clause. A table expression is the foundation of any SQL query. It can be in Postgres, it can be in Oracle, it can be in other databases. So it defines where the data is coming from, and it can be a simple table or it can be a complex subquery or it can be a view, and there are lots of options. So the from clause plays a central role in table expressions, specifying which tables or data sources are being queried. So let's see the basic table expression structure. The basic structure is like this: select, then the list of columns name, then the from, and then the table expression. The table expression may contain subqueries, may contains the where conditions, may contains group by, having clause, and lots of options are there. So let's start with a simple example. So for that, let's create the table called employees. So employees table is created and we insert some data into the employees table. So four records are inserted into the employees table. Now let's create another table called departments and we insert some data into the departments table. So the data are inserted and we can verify them by checking the data from the employees table, and also we can do the same for the department tables. So the data are inserted. So here we have created two tables, one is employees and one is department, and we have inserted some data and we performed one basic query, that is select asterisk, that means list of all the columns should be retrieved, and then the from and then the table name. So this was the basic example of the from clause in PostgreSQL database. Now let's discuss about table inheritance in from clause. So PostgreSQL supports table inheritance, which means a child table can inherit properties from the parent table. This thing we have discussed in one of previous video. I'll share the link in this. So if you have missed the inheritance chapter, you can cover that. So let's create a table called managers that inherits the employees table. The thing is, the managers table will contain one extra column that is called bonus column. So let's create the table called managers, and it inherits the employees table. And now let's insert one data into the managers table, and here you can see that we are inserting all the data columns and also we are including the bonus column. So let's insert one record into the managers table. So managers data is inserted. And now what will happen when I query this employees table? So this employees table will bring the record of the managers as well, because this is inherited data. So let's query and I'll show you. So here you can see the manager data is returned from the query. This is because we had inserted data into the managers table, but the managers table inherit the employees table. So the data goes into the employees table as well. But what will happen when I query from the managers table, select star from managers? So the only managers data will be retrieved. So we can see that managers data is retrieved with the bonus column as well. And if we want to see the data of only employees table, not the inherited data, so for that we use the only keyword. So how we do that? So select star from, then instead of writing the table name, so we mention a keyword only. So that means it will retrieve the data from the employees table only, not the managers data. So let's see. So here you can see that managers data is not available because we have inserted managers data into the managers table, and the inherited data we have excluded using the only keyword in the from clause. Now let's discuss about the cross join or the Cartesian product in PostgreSQL database and how we use in the from clause. A cross join generates a Cartesian product, meaning every row from the first table is paired with every row from the second table. So this happens when we don't mention any where clause, or we omit the where clause condition, or we don't join the table properly. So let's see an example of cross product or the Cartesian product. So this is an example of a cross join. So how we do it? So select star from, then employees table, and then the cross join the department table. So what will happen in the employees table? We have 5 record if you see, and this includes the inherited data as well. So in the employees table we have 5 record, and in the departments table we have 3 record. So this will be multiplied and we will get total 15 records, and this is why we say it as a Cartesian product. So here you can see that total rows returned are 15, and this can also be written like this: select star from, then employees table, comma, then the second table name, and this is also does the same thing. So since we omit the where clause or the joining clause, so that gives us the Cartesian product. So now let's see another join, that is the inner join. That inner join combines related data only. So an inner join returns only the rows that have matching values in both the tables. This is the most commonly used type of join. So for that, let's create a statement, that is we are getting the details of employee and the department name. So how we join them, the table employees, and we have joined the department table, and this join is done on the basis of the department ID. So department ID of employees table is joined to the department's ID of the department table. So if we query this, we will get the data where the details are matched. So here we got the result as these three record match the data properly. You can verify from the given data that we have inserted into the tables. So this retrieves only those employees whose department matches an entry in the departments table. Now let's see the outer joins. There are three types of outer join. One is left outer join, right outer join, and then full outer join. So outer joins help retrieve unmatched rows as well. So including the matched rows that we have got in this result set. So apart from this result set, we'll get the extra rows. So let's see them one by one. So first we'll cover the left join. So left join, how it works. So left join will give all the record from the left hand side table. Okay, so even if there is no matching data from the right hand side table. So for that, let's say we have this kind of query that select and those columns are there, and we are getting the from employees table. So employees table is the left hand side table, so all the employees data should be retrieved. So in this case, 5 employees record should be retrieved, and left join departments table, and we are joining on the basis of department IDs. So even if department ID is not present for some employees, that employee data will be retrieved, but the employee department name will be null value because there is no department for that employee. So let's retrieve the data. So here we can see that all the 5 records of employee are returned, but wherever the department name is not available, so that record is not excluded, but we got that data but with the null value for that. So this is how left join works. So the next is right join. The right join is exactly opposite to left join. So all the data from the right hand side table will be retrieved even if there is no matching data for the left hand side table. So in this case, we are doing the same thing. We are joining the employees and right join departments. So all the department value will be returned even if there is no employee with that department value. So for example, here HR and IT department employees are present, but there is one more department that that is having no employee. So that department detail will be retrieved. So let's query that. So here we can see that we have received three matching record that are having the departments, but one more department that we have, that is called marketing, but we don't have any employees of marketing department. So for that, the employee name and the employee salary is null value, but still we got the department name data. So this is how right join works, and the combination of left join and right join is the full outer join. So in the full outer join, what happens, all the eligible records will be retrieved that matches exactly, and then the result set of the left outer join will be retrieved, and the result set of right outer join will be also be retrieved. So let's query that, and the syntax is like this: select then the list of columns, then from, then instead of writing the left join or right join, so we need to mention here full outer join. So let's query this one. So here we have received 6 record in total because 3 are the matching one, the first one, second one, and this one is the correct one, and these 2 records are the result of left outer join, and the last record is the result of the right outer join. So this makes the query as full outer join. So these are the different joins that helps handling the data relationships effectively. Now let's see table and column aliases for readability. So aliases is a substitute name of any column or any table we can give that is suitable to remember, suitable to use, or suitable to read. So aliases help simplify long table or column names, making queries easier to read and write. So let's see an example. So we are doing the inner join of employees table and department table. So instead of writing employees.name, employees.salary, departments.department name, so we can give any shorter name or that can be understandable or that can be readable quickly. So we are giving it the alias of E to the employees table, and we are giving the alias of D to the department table. So we can omit this as a keyword, that is optional to give the alias. So if we write this, that is okay. If we omit this, that is also work. So let's query this. So this should return three records that are applicable for the inner join. And now let's see using subqueries in from clause. So a subquery can be used in the from clause to create a temporary virtual table. So for example, so till now we used to get the data from the from table directly. So instead of doing that, we can create one temporary virtual table where we can get the data. So we can say like this: select average salary then from employees. So this much is a subquery where we have used the from clause, and this makes one runtime virtual table, and from that table all the queries can be performed. So this is one of the simplest example of this kind of subquery, and here we are trying to get the average salary of employees. So let's do it. So the average salary of the employees are returned here. So here we use a subquery to calculate the average salary before selecting it. And now let's see the lateral subqueries. Lateral subqueries allows a subquery to reference columns from preceding tables in the from clause. So instead of writing the entire query or entire table join, so we can use the subquery to do it. So for that we use the lateral subquery. So in this case, what we are trying to do, we are trying to get the employee detail, all the details from the employees table, and we are trying to get the department name for all the employees. So this is how it is done. So we are writing select star from employees, then comma, then we write lateral, then in the subquery we mention the department name we need to get from the departments table, and then the join condition as required. So let's query this one. So here we have got all the data that are applicable for the inner join, and here we can see that department name is returned HR, IT and HR. So the lateral subqueries enable dependent subqueries within the from clause that provides greater flexibility. And next, let's see the table functions in from clause. So table functions return sets of rows and can be used just like tables. So in one of previous videos, we have discussed about the function that returns the set of records, that returns the tables, we can say. So this is an example of that. So here we are trying to get the employees data where salary should be the greater than one salary that is passed in the parameter. So we are creating one function called get high salary, and we have one input parameter that is p salary limit, and the type is in numeric, and the return type is set of employees. So set of employees record will be returned in the output. So first let's create this function. The function is created, and now let's use the function in the from clause. So select star from the function and then the input parameter. So here we are trying to get the employees that is having salary more than 70,000. So let's query this one. So all the data of employees are written who are having the salary more than this salary provided in the input parameter. So this function fetches employees earning above a specified salary that is given as the input parameter. So in this video we have covered the from clause, table references, inheritance, joins, aliases, subqueries and table functions. So this is all about the from clause in PostgreSQL database, and in the next video we'll cover the topic of the where clause in PostgreSQL database. So if the video was helpful, do like the video and subscribe the channel to get the notifications for upcoming videos. So let's meet in the next video. Till then, take care. Bye bye.